Welcome to the program here on exponential growth. So if you've seen this problem here, a would you rather problem, the question is, would you rather have $1 million or a penny on the first day, 2 pennies on the second, 4 on the third, and so forth. So we're going to create a program that's going to help students generalize this for when the pennies become more than that $1 million. So how many days that this ends up taking. So the first thing that you'll see that I did in this program is I came down and I added a sprite. So I uploaded this picture, this would you rather picture from online. And I also created in the paint tool, so coming here, another sprite, this days repeated to help us with the variable here. So the first thing I'm going to do here is we want to create a handful of variables. So I'm going to come to the variable tab on the left and hit make a variable. The first thing we want to start with is the day one amount. It's what we receive on the first day. Another variable we'll call days, so how many days we're repeating this. The multiplier, so what is our penny amount multiplying by each day. We're going to need a total amount of money, as well as we're going to call it a temporary total for our variables. Now you'll notice right now that all of these have these blue checks next to them, which means they're appearing on the screen to the right. The only ones that I'm going to choose to display for our program here is days and the total. So I'm going to end up putting days repeated, we'll put here, and we'll put the total amount of money over here on the right, so underneath these pennies. And you can set yours up however you'd like. Maybe I'll keep this as total. So to change this display, I'm just double clicking, and there's many ways we can display these variables. So to get started, typically as we start a program, we'll start here with the green flag. So as this green flag is clicked here on the right, anything below it is going to happen. So the first thing we want to ask is what is the amount of money on day one that we're receiving? Now whatever is typed in here from the user, whatever answer they type in is going to be stored in this answer block. So what we need to do is set this variable, this day one amount, to the amount of money that they type in. The next question we want to ask is, what is your money being multiplied by each day? And in this case it's doubling, so it's going to be multiplied by 2. But again, we want to set then our multiplier to the answer that this user types in. The final question here we're going to ask is, how many days will you follow this pattern? So how many days are you going to be receiving this money? And we'll set the days to the answer that was typed in. So right now, everything that's typed in, the initial amount, what is our money increasing by? So in this case, it's doubling. And how many days are we going to follow this pattern? So the next piece, we're going to need a loop here. So the first thing we want to do is set our temporary total, because this is going to change throughout our loop. And we're going to set this to our day one amount. So our total amount of money after day one is the amount that they type in initially. Now the loop here, we'll break this down into a few pieces. So we're going to come to control and pull out a repeat block. So we want to repeat this for as many days as we're asked. We're going to receive a penny on day 1, a penny on day 2, on day 3, so forth. But because we're working with a sequence here, we're working with n minus 1 as our value for our days. So this is a great conversation to have with kids. We're going to have our days minus 1 for the total that we're going to repeat, since we're starting with day 1 and not term 0. Now what we want to happen within this loop is every time this loop reoccurs here, we want to multiply our initial amount here by 2 every single time. So we're going to come into operators and grab a multiplying block, and we're going to multiply by 2 every time we run through this loop. But what's going to happen is we're going to take our temporary total and multiply this by 2. So if we think about this in our loop, we start with 1 penny and we're multiplying it by 2. So now it's 2 pennies, and then we're running this again. Now it's going to be 4 pennies, doubling again, 8 pennies, so forth. And we're going to do this, if we did this for 5 days, we would run this loop 4 times to get that total. Now at the end of this program, I like to set here our final total to display on the screen. So once we run through this loop the number of times needed, we're going to set our final total to that final temporary total value. And let's run this and see what happens. So the amount of money on day 1, we're going to have 1 penny. We're multiplying by 2 each day. And let's follow this pattern for, let's just do 3 days so we can see that this should come out with 4 cents. So great, because we come out here when we ran this program and we did however many days we repeated here, we shouldn't come out with 1 penny at the end. So we've got an error within our code. And we'll see here right in our set, we need to be setting our temporary total to this new value doubling each time. So this is why code is so great, that students shouldn't immediately be able to check that their answer is either correct or incorrect. So we'll go try this one more time. 1 penny, we'll do multiplying by 2 for 3 days. And there we go, 4 cents. We've got 4 pennies on that 3rd day. And we could run this over and over to try and figure out when is this exceeding $1 million. And this is the value of this program. It really does save that time on the computation. Best of luck.